let's begin our discussions in lesson 0-4, counting techniques. If you're looking at the instruction, the very top of the your classwork, you will see that use the fundamental counting principle to determine the number of outcomes. Looking at the table, you see that you have several options of sandwiches, size, and beverages. They asking how many different combinations of sandwich, size, and beverage are possible. So we already discussed about fundamental counting principle, so let's just apply it right away. As you can see, we have in sandwich side we have hot dog, hamburger, veggie burger, and the breadwurst and grilled chicken together. You have 2, 4, 5. So let's say you have 5, and then you multiply by the side. You have chips, apple, pasta, salad, 3, and then you have the beverage. You have 2, 4. So you multiply together, you will have 60 possible outcomes. Let's go down to number 2. In number 2, you have a multiple choice questions. You have 5 questions, and each of the question you have the choice A, B, C, and D. Now how many possible is that? So as you can see, 5 questions. So if 4 times 4 times 4 times 4 together 5 times, or you can say 4 times 4, you have 5 questions. First question, second question, times 4, third question, times 4 again, the fourth question, and then 4 again, the fifth question, and you multiply together, you will have 4 to the fifth root, just 4 to the fifth, you will have 1024 possible outcomes. How many different ways you can answer the question. So there are 1024 ways of answering the question. Number 3, looking at the different way that he can choose his tuxedo. He has already chosen his jacket, so which is one option, and then after that he must choose from 3 different types of pants, so 3 times 3, and then 6 colors of vest, so times 6. So together, one jacket, 3 different types of pants, and 6 different colors of vest. So multiply together, he will have possible outcomes 18 attire for his prom. He has 18 different ways he can select his attire. Number 4. Now number 4, looking at the table again, they have all this kind of options, size, and different choices that they have. So size, you have size, you have 4 choice, type of positions, you have 3 choices, and materials, you have 2 choices, and levels of quality, you have 2 choices. So I think in this case you might get confused. You might get confused with the options, the number of choices, but it's not the case. You see, choice in size, option, you have size. In size you have 4 choices, and you multiply again to types of position, you have 3, and you multiply again of material, you have 2, and you multiply again with the level of quality, you have 2 also. So as you multiply together, you will have 48 different gloves are possible. So I hope you will not get confused with you might count the option as size, types of position, materials, and level as another 4 number to multiply. No, it's not the case. Well, I'm not going to discuss with you with P 6 taken 3, or P of 7 taken 5, P of C of 2 taken 2, or C of 12 taken 7. That obviously very easy to use, so I will not going to talk about that section. Let's go down to number 9. When number 9, they said determine whether each situation involves permutation or combination, then solve the problem. Well, I hope you still remember what permutation and combination is. I'm not going to talk about it, but I'm going to tell you right away whether it is permutation or combination, and then we solve the problem together. So number 9, looking at the situation, 6 different class next year, assuming that each class is of each period. Because this one here involving sequence, first period, second period. So this is a permutation. So permutation. So permutation of what? Well, after that, you need to solve the problem, the permutation. And the question, how many different schedules could she have? Okay, they're asking for how many possible schedules could she have if it is a permutation. So, of course, permutation is P. So, she has 6 different classes. So, gonna be a permutation of 6 subjects, and she's going to arrange all her 6 subjects in her schedule. So together she will have 120 possible schedule that she could have arranged as 6 subjects. Number 10, how many 4-color groups can be selected from 13 different color balloons? Well, this doesn't require any ordering or any ranking, so obviously it's a combination. So it's a combination represented by C, and C of 13, and they need only 4 colors out of the 13, so 4. So you have a combination of 13 and you taken 4. You will have 715 possible group that can be selected from this 13 balloons, color balloon, and taken 4. Number 11, how many different ways are there to choose the winner and the first, second, and the third runners-up in a contest with 10 finalists? Okay, so as you can see, this is obviously a permutation. Talk about ranking, first, second, and third. So we have a permutation, and then permutation of, together they have 10 runners, and they need to choose the winner, the first, second, and third. So a permutation of 4, a permutation of 10 taken 4. If you're going to calculate this one, you will have a 5,040 possible ways to choose the winner, the first, second, and the third. Number 12. In number 12, a band choosing 3 new backup singer. Okay. So situation doesn't require any, ordering or ranking. Anybody could be randomly selected. So it's a combination. Now, combination of, what is it? Combination, among the 18 singers, they choose 3 for their backup, 3 of them. So a combination of 18 taken 3. If you're going to calculate this, you will have 816 possible ways of choosing the backup singers. Okay, for number 13, it is obviously a combination. As you can see, how many different topping pizza can be made if there are 6 options for topping, it's a combination because there's no ranking or ordering inside it. So a combination, so C of 6, and you select only 2 out of 6, so by that you will have 15 possible different topping pizza, 15 of them. Continue to number 14. In number 14, how many ways can the manager do a softball? Manager of a softball team choose player to play top 4 sport. Okay, in the lineup. Alright, top 4 sports. So we again talk about ranking this time. Top 4 sport in the lineup. If she has 7 possible players in mind. Okay, so back to the top 4 sports. So in that's the keyword. That's the ranking. So since it's like that, it's a permutation. So P, permutation. And then she has 7 person in mind, but she choose only 4 to play. So if going to calculate that one, is a permutation of 7, she taken 4, so she will have 840 possible choices that she could make to put players in the line. That's for number 14. Number 15. Okay, number 15. Jack has a department store has 9 employees available to cover 4 different sections of the store. How many ways can employee be assigned? Okay, be assigned, this it's somehow you might get lost in this part. This thing is a combination, because the employer can just arrange anybody to cover that 4 sections randomly, but it's not really the case, because the question to be assigned to give the position to the person to really put ordering in them. So is again, this is a permutation. So the store manager has 9 employees, so permutation of 9 employees, and you need 4 different sections, so need 4 employees to cover the 4 sections. So if you're going to calculate that, you will have the department store will have to assign, as we have 3,024 possible ways to assign the employee to cover the 4 sections. Number 16. Number 16, Jack has a reading list of 12 books. How many ways can he select 9 books from the list to check out of the library? What is the combination? Just a list doesn't necessarily that the first should be the first book to read. It's just a list of books. So it's a combination. So combination of, he has 12 books and you need 9 from the 12 book to read. So it's combination of 12 taken 9. If you're going to calculate that, you will have the answer as 220 possible ways that he can select the 9 books. Now let's move on to the last number 17. Number 17, this talk about restoring password. 6 the password, 6-character password. Okay, password can contain either letters or digits. Okay, so as in now we have a combination of mixing letters and digits together. So now we have 26 alphabets and we have 10 digits, so together you will have 36 characters together together to choose from to make 6-character password. So question A, how many passwords are possible if characters can be repeated? Again, let me repeat the question. A. 17a. How many passwords are possible if characters can be repeated? Okay, so this is somehow a is somehow a fundamental counting principle. We need to apply this together, So let's say you have in the first digit, first character of the password, you choose among the 36. Now they can be repeated. So again, it could be happen again. So you choose again among the 36, and the third character you choose again among the 36. The fourth character of the password you choose again among the 36. The fifth character you also choose among the 36, and the sixth. Okay, we have the first character, the second, the third, the fourth, the fifth, and the sixth character. You're also choosing among the 36 character. So you just multiply the three together, give you about 2 billion something. So you need to find this one out by yourself. I will give you the key to do it. Get it by yourself. Just multiply it. And then let's continue. That's for first section. Okay, now second section A. If no characters can be repeated. Okay, if no character can be repeated, so it seems that the ordering the ordering is important in this case. So it will fall into a permutation way. So in other words, you have you can put as permutation of 36 taken 6, or it could be just 36 multiplied, since the character cannot be repeated, so one already taken out, so you have only choose among the 35, and the third one choose among the 34, choose among the 33, choose among the 32, and choose among the 31. So if you multiply together, this is 6 character, 1 2 3 4 5 6. Okay, you multiply together, you will have the possible password if no character can be repeated. That's for section A, part 2. Now let's move to our last section in question 17. Section B. How many passwords are possible if all characters are letters? Okay, if all characters are letter that can be repeated. Okay, that's obviously in this part not really a big deal to you. It's easy, if all characters, so you have 26 character, so if all characters 26, so part B you will have just 26, and obviously and they said it can be repeated. So first character choose among 26, second also choose among 26, choose among 26, choose among 26, choose among 26, and choose among 26. 1 2 3 4 5 6, and you multiply together, you will have your answer, I think around 300 something millions. So make sure you multiply this and get your answer. Make sure to write the answer down. Second section. If the password must contain exactly 1 digit. Okay, you need to find how many password is it. So let's talk about the exactly 1 digit. How it, what kind of possible a way to write this password, So it seems like you have 20 letter 1 2 3 4 letter, and then you have digit. So exactly 1 digit, so this 1 digit. So or the digit could be at the last, the first, it could be here, the second could be the third, could be the fourth, could be the fifth, so the digit, it can be run around the sixth position. You don't know, is it in first, second, third, fourth? We do not know which is it. As long as the password has one digit, it is what they want. So this is one of the possible way, or it could be this way. One, two, three, 1, 2, 3, 4, 5, 6. Could be this way also. So if you're going to list down, you will see that this way, the digit that has the password that has exactly one digit, it has it has 6 different forms. So if you're going to find the answer of this form, once you have the answer of this form, you just multiply this with 6 times, because if you're going to list it down, it's going to be up to 6 times. So you multiply by 6 times, the answer will give you about 700 million something. I will not do the calculation for you. You have to do it by yourself. So this is about 3 million, about 300 something millions. And this part about 712 million. So you need to complete the last 6 digits by yourself to get to the correct answer. That's all I can help you with this. I will not going to calculate this one for you. You need to do this one by yourself, So after you find the answer of this section and this section, let's go to the last part. They're asking in the question, which type of password is more secure? Explain. They're asking you, is this type secure, more secure, or this type more secure? You see the option right here. Is it 308 million, some 8 millions password, and this is about 712 million password. So if you're going to guess, in this case, you have less password for them to guess. This have a bigger password for them to guess. So the higher the number of password to guess, the more secure. So less number of guess, less secure. More number of to guess, more secure. So in this case, the password that has exactly one digit is more secure than the password that contain all the alphabets, the letters. Explain why? Because this has more choices to guess, which just make it harder for them because of a lot of password to guess than this one. That's all. I hope this will help you a bit to understand. So whenever the teacher gives you the work, even though he might change the numbers around, you will be able to do it because you will understand the concept of doing these problems. Good luck.